Welcome to Tech Turbo. In this video, we will tell you how scientists finally discovered a new way to travel faster than light. Faster than light travel is possible. It sounds like the stuff of science fiction, but spaceships that travel at warp speed are possible, according to one top scientist. In a recent study, physicist Dr. Erik Lentz outlined a way that a rocket could theoretically travel faster than light, or over 186,000 miles per second. At that speed, astronauts could reach other star systems in just a few years, allowing humanity to colonize faraway planets. Current rocket technology would take roughly 6,300 years to reach Proxima Centauri, the closest star to our Sun. So-called warp drives have been proposed before, but often rely on theoretical systems that break the laws of physics. That's because according to Einstein's general theory of relativity, it's physically impossible for anything to travel faster than the speed of light. Dr. Lentz, a scientist at Göttingen University in Germany, says his imaginary warp drive could operate within the boundaries of physics. While other theories rely on exotic concepts such as negative energy, his gets around this problem using a new theoretical particle. These hyperfast solitons can travel at any speed while obeying the laws of physics, according to a Göttingen University press release. A soliton, also referred to as a warp bubble, is a compact wave that acts like a particle while maintaining its shape and moving at a constant velocity. Dr. Lentz said he cooked up his theories after analyzing existing research and discovered gaps in previous warp drive studies. He believes that solitons could travel faster than light and create a conducting plasma and classical electromagnetic fields. Both of these concepts are understood under conventional physics and obey Einstein's theory of relativity. While his warp drive provides the tantalizing possibility of faster than light travel, it's still very much in the idea phase for now. The contraption would require an enormous amount of energy that isn't possible using modern technology. The energy savings would need to be drastic, of approximately 30 orders of magnitude, to be in range of modern nuclear fission reactors, Dr. Lentz said. Fortunately, several energy-saving mechanisms have been proposed in earlier research that can potentially lower the energy required by nearly 60 orders of magnitude. The astrophysicist said he would now focus his efforts on cooking up a workable version of the technology. This work has moved the problem of faster-than-light travel one step away from theoretical research in fundamental physics and closer to engineering, Dr. Lentz said. The next step is to figure out how to bring down the astronomical amount of energy needed to within the range of today's technologies, such as a large modern nuclear fission power plant. Then we can talk about building the first prototypes. The research was published in the journal Classical and Quantum Gravity. Negative energy. The idea of creating warp bubbles is not new. It was first proposed in 1994 by the Mexican physicist Miguel Abarrier, who dubbed them warp drives in homage to the sci-fi series Star Trek. However, until Lentz's research, it was thought that the only way to produce a warp drive was by generating vast amounts of negative energy, perhaps by using some sort of undiscovered exotic matter or by the manipulation of dark energy. To get around this problem, Lentz constructed an unexplored geometric structure of space-time to derive a new family of solutions to Einstein's general relativity equations called positive energy solitons. Though Lentz's solitons appeared to conform to Einstein's general theory of relativity and remove the need to create negative energy, space agencies will not be building warp drives anytime soon, if ever. Part of the reason is that Lentz's positive energy warp drive requires a huge amount of energy. A 100-meter radius spacecraft would require the energy equivalent to hundreds of times the mass of the planet Jupiter, according to Lentz. He adds that to be practical, this requirement would have to be reduced by about 30 orders of magnitude to be on par with the output of a modern nuclear fission reactor. Lentz is currently exploring existing energy-saving schemes to see if the energy required can be reduced to a practical level. Any warp drive would also need to overcome several other serious issues. Alcubierre, who regards Lentz's work as a significant development, cites the horizon problem as one of the most pernicious. A warp bubble traveling faster than light cannot be created from inside the bubble, as the leading edge of the bubble would be beyond the reach of a spaceship sitting at its center, he explains. The problem is that you need energy to deform space all the way to the very edge of the bubble, and the ship simply can't put it there. Spacecraft doubts. Lentz describes his calculations in classical and quantum gravity, where other recent research on the topic is outlined in an accepted manuscript from advanced propulsion laboratory researchers Alexei Bobrick and Gianni Marchire. The duo describes a general model for a warp drive incorporating all existing positive energy and negative energy warp drive schemes except Lentz's, which they say likely forms a new class of warp drive spacetimes. However, they argue that a Lentz-type warp drive is like any other type of warp drive in the sense that at its core, it is a shell of regular material and therefore subject to Einstein's cosmic speed limit, concluding that there's no known way of accelerating a warp drive beyond the speed of light. Though he recognizes these huge hurdles to building a warp drive, Lentz feels they are not insurmountable. This work has moved the problem of faster-than-light travel one step away from theoretical research in fundamental physics and closer to engineering, he says. After addressing energy requirements, Lentz plans to devise a means of creating and accelerating and dissipating and decelerating the positive energy solitons from their constituent matter sources, then confirm the existence of small and slow solitons in a laboratory, and finally address the horizon problem. This will be important to passing the speed of light with a fully autonomous soliton, he says. So has Einstein been proved wrong? It is inaccurate to argue that Einstein proved that no object could travel either at or faster than the speed of light. The scientist showed that this ultimate speed limit, 300,000 kilometers per second, or about 1 billion kilometers per hour, applies only if space and time are not distorted in any way. If you warp space-time around a spacecraft, Einstein's equations suggest there is no limit to how fast we could travel through the galaxy. How do you warp space-time? If you were Scotty on the USS Enterprise, you would do it using a mixture of matter, antimatter, and fictional dilithium crystals. Exactly how the Star Trek engineer used these to bend space-time is unclear, but in the real world, it can be done using certain types of matter and energy. In the mid-1990s, theorist Dr. Miguel Albuquerque in the Cardiff University in Wales showed that it is possible to outpace light by warping space-time so it shrinks in front of a spacecraft, thus bringing its destination closer while pushing it away from its rear. But calculations showed that doing this would need vast quantities of strange material with anti-gravitational powers, which no one knows how to make. Now, an astrophysicist has revived this warp engine idea by finding new ways of bending space-time. What's the trick? By digging deeper into Einstein's complex theory, Dr. Erik Lentz, a physicist at the University of Göttingen in Germany, has found ways of traveling faster than light by creating new types of space-time bubbles around a spacecraft. Known as solitons, they are similar to those proposed by Dr. Alcubierre. Crucially, however, Dr. Lentz has discovered that some of these bubbles can be formed using ordinary matter. This is the first known solution of its kind, said Dr. Lentz, who reported his breakthrough in the journal Classical and Quantum Gravity. His calculations suggested that a standard type of matter known as plasma, a kind of gas of positive and negative charges, could do the trick of warping time-space around a spacecraft. Remember that a warp drive can modify the region of flat space-time it encloses. It can, in particular, speed up or slow down a clock inside the drive. Consider what it would mean to have such an object available. Want to put someone with a terminal illness on ice? Stick them in a warp drive and slow their clock down. From their perspective, a few years will pass, while 100 years will pass on Earth. Time enough to find a cure. When will we see the first real starship? There are a few technical hitches to be resolved. Dr. Lentz estimates that making a spacecraft such as the Enterprise travel faster than light would require the amount of energy equivalent to that needed to destroy a small star. Even so, he believes technological advances will drastically reduce this figure, perhaps in a matter of decades. The payoff would be huge. Using current rocket propulsion, it would take more than 50,000 years to reach the nearest star, Proxima Centauri. Traveling at light speed, the journey time would be cut to about 4 years. Do let us know in the comments what you think of this future development. Thanks for watching.